Guys, welcome back to TechDose, and in this video we will look at the remove subfolders from the file system problem, which is from Leetcode number 1233. We will look at the optimal solution. A prerequisite before watching this video is to watch my video on trie. So you can click on the I button and you can also find the link of the trie video in the description below. Now let's look at the problem statement. In this problem, given a list of folders folder, return the folders after removing all the subfolders in those folders. You may return the answer in any order. If folder of I is located within the folder J, it is called a subfolder of it. A subfolder of folder J must start with folder J followed by a slash. For example, /a/b is a subfolder of /a, but /b is not a subfolder of /a/b/c. The format of path is one or more concatenated string of the form slash followed by one or more lowercase English letters. For example, /leetcode and /leetcode/problems are valid path, while an empty string like a slash is not a valid one, right? Now let's look at an example for better understanding. In this case, we are given folders in a file system. So let's say that our folders string array is /a/b and so on, right? Now our goal is to print all the main folder paths. What do I mean by main folder path? Now I have already created a file system tree structure. In this case, the root will always be present, and if you consider the root is always present, and if I insert /a, then you see we have inserted /a here, right? Now if you insert /a/b, then it will come in the same path of /a, and then a /b will get inserted. But in this case, you will find that /a/b is inside /a folder, which is already existing, and that is why this is a subfolder. /a/b is a subfolder of /a, and therefore this will not be accounted for in our answer. Now if I try to insert this /a/d, you will see this /c and /d gets inserted. Fine. If I now insert /c/d/e, then we will be going to C, D and E. But you look at it, CDE is contained inside CD, which is already a valid folder, and that is why this becomes a subfolder of CD, and therefore this will not be included. Again, if you look at this CF, then we will be going to the root node, create a C and create an F. Now CF is independent of CD, it is not contained inside CD, and C is not a valid independent folder, and that is why this is not a subfolder. So our answer in this case will be A, CD and CF. You will see A, CD and CF, and we can return this answer in any order, so ordering is not important as long as we give the exact same folder names. Okay, so I hope the problem statement is clear. Now from this problem we can just take out some observations. The first observation is the name of the folder can be even a string like /doc/personal, or it can be videos, movies, Harry Potter, right? So the Harry Potter movie is contained inside the movies folder, and movies folder is inside the videos folder, right? And the videos is inside the /, which is the root node. Now all these names are separated by a /. Okay, so this should be kept in mind. All the letters are lowercase letters as well. The second point is we can create the file system using an n-ary tree. And the most popular n-ary trees for implementing file systems are the LCRS trees, which is left child right sibling trees, and also the tries. So in this case we will be solving the problem using trie. The third thing we to note is root of the file system / will always be present, as I said. Okay, now since we will be solving it by trie, let's look at a dry run, and we will be using the pruning technique to skip the unwanted folders creation. Okay, you will learn about pruning in the dry run itself. So let's see this structure of the trie node. We have a word end value indicating that if a string or a folder is ending at a certain node, then I will set it true, otherwise it will be false. And I am assuming that you have already watched my trie videos. Okay, now I will be taking a map to make an array of pointers, right, just to create an n-ary tree structure. So the string, which is the key part of the map, will be storing the current name of the folder, and the trie node star is actually the pointer to the subfolder which this current folder will be containing. Okay, and the name of this entire map is child, right? So this is the structure. So our first step for creation of the file system will be to do insert operation for all the folders. So our root will always be present by default. Okay, so let's have a root node. Our root will always be present by default. In this case, I will be inserting the first one, let's say home and study. So do we have a home folder? No, we do not have an home folder. So let's make a home folder. And inside the home folder, I should have a study folder, which is not present. So let's have a study folder too. So once we have ended our entire parsing, then I will be setting the word end equals to true here. So let me call it as 1. 1 means true. For all the rest of the values, the word end will always be 0. So for 0, I am not writing them. You can just assume that they are 0. Now the important thing to note here is you have to extract all these values, and the extraction can go from one slash to the next slash. So in between the slashes, the entire string will become the folder name. Okay, so this is how you can extract. I will show you in the code how to do that. Let's insert the second one. So when you insert the second one, do we have a path to docs from the root node? No, so create it. Do we have a path to loan under docs? No, so create loan. And inside loan, do we have personal folder? No, so let's make a personal folder. Now all these folders have been created. The last one has to have word end equals to 1. Okay, so this is done. Now let's look at the third one, which is docs and loan. So we will go inside the slash. Yes, docs is already present, so no need to create that. Then we will go to loan. Yes, loan is already present. So I will be writing a word end equals to 1 because docs loan is a valid folder, right? Now we will be doing the next insertion, video tutorials. So from the slash, do we have a path to videos? No. So I will create a path to videos. So videos is a new folder inside the root node. Then we will create tutorials under it. So tutorials. And I will be setting word end equals to 1 in this case, right? Now let's look at the next case, which is home study OS. So from the slash, do we have a home folder? Yes. From home, do we have a study folder? Yes. So after the study folder, we need to go to the OS. But you look at it. One valid folder is already ending at study. So even if I create an OS inside the study, it does not make sense, right? Because this will be eventually a subfolder inside a valid folder, which is home study. And that is why it will never be contributing to our answer. And there are no deletion operation in the entire problem. So OS will never come into our answer set. So whenever I see a word end equals to 1 while doing the insertion, I will stop there and I will simply return. I will not create this OS folder. Okay. So this will not get created. Fine. Let's go to the next one. Videos, tutorials and CPP. Let's go to the root node. From here, do we have videos? Yes. Do we have tutorials? Yes. But we have a word end equals to 1. Again, videos tutorials is a valid folder, and inside this I do not need to create CPP because this will never contribute to our answer. So what we are effectively doing is we are removing all the impossible answers, and therefore technically we can say that we are pruning, right? So this technique is called pruning. Now the next part is docs loan home ID. You look at this docs and loan. When you go to loan, you see that word end is equals to 1. So I do not need to even parse the rest of the part, and I can say that whatever is the rest of the part will definitely be inside loan, and that is why they will never come into the answer. Now if you look at this personal, how did personal come inside loan? Because personal was created first. You look, docs loan personal came before docs loan, and that is why this personal is here, right? Otherwise it would not be present. So that is why this will also be not inserted. Now this is the creation of the file system using the trie and pruning technique. Now after having done all the insertion, we will be simply doing the DFS technique, and we will be traversing from the root node, and whenever we see a word end equals to 1, then simply I will be printing that path. So we have to maintain this path whenever we go. You can use a stack, you can use a list. I will be using a list. So whenever you travel from the root node, so whenever you jump from one node to the next node, then you should append a slash to your string. Okay, so initially what I will do is I will always be starting from a slash. So when I am at the root node, I will be starting with a slash. This will be called as a path. Okay. Now when I go to the next node, which is home, then I will be pushing home inside it. Then again I will append a slash and go to the next node, and I will be appending a study, right? Now at the study, I see that the word end equals to 1. So this is one of my path which will be pushed into a list of list. Okay. and now I will be backtracking from here. When I backtrack, do I have any other path coming out of home? No. So I'll be backtracking to the slash. Okay, now when I go here, I will be going to another path. So a new path gets created. We will be passing the path by value, not by reference. If I pass by reference, I have to pop out these items when I backtrack. Okay, so this needs to be taken care of. Now when I go to docs, I will be pushing docs inside the slash. Again, the word end is not 1. So I'll be going to loan and I will be pushing loan. Now loan has word end equals to 1. So I will not go further. I will just backtrack. And this will be one of my answer, right? When I backtrack, I will be popping off this loan and my path will be docs only. Now from docs, there are no other paths. So when I backtrack, I will be removing the docs as well from my path. Now the third path is go to videos. So I will start with the slash and I will go to videos. And when I go to videos, is the word end equals to 1? No. So I will be going to the next one, which is tutorials. So I'll be saving tutorials as well. Now at tutorials, you will find the word end is equals to 1. And that is why this one will also be contributing to a valid path, right? And if I backtrack, I will be popping off these tutorials. And again, from videos, there are no other options. So I'll backtrack. I'll be popping off these videos as well. Now from the root node, we do not have any other path and we will backtrack and finish up our DFS call, which is the recursion and backtracking call, right? So we have found 3 unique main folders, which are home, study, docs, loan, and videos tutorials. So you can see that we have created home, study, docs, loan, and video tutorials. All the rest of them like docs, loan, personal is inside this docs, loan, home, study, OS is inside the study folder. Now video tutorial CPP is inside the tutorials folder. Docs, loan, home, ID is inside the loan folder, right? So there are 3 main folders and that is why we got 3 answers. I hope you were able to understand this trie and pruning approach. Now in this case, I will assume that the total number of folders are n and the length of each of the folder is L. And that is why, since you need to process each of the folder character by character to extract the folder name, so we have to parse the entire length of the folder, right? And we have to do it for all the folders. And that is why, since the time complexity is linear in our trie, so it will be n times L. And the space complexity would be all the folders could have been unique and could have generated unique paths. And so the space complexity will also be n times L. In the constraint section, if you remember, n is less than equals to 4 into 10 to the power of 4. L is less than equals to 100. So if you see this NL, it will be less than equals to 4 into 10 to the power of 6, which is less than 10 to the power of 8. And that is why this will definitely run within 1 second. And this is an optimal approach. So let us now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. Now in this case, we are asked to remove the subfolders and we are given the folders array. So I'll be creating the root, which is the slash, which is the starting point, right? And we will be inserting all the folders one by one into the trie using the pruning technique, as I had already explained. And once you have done this, then I will be creating a result list of string, which is actually storing all the paths. And we will be doing a DFS call using the search trie. I will pass the root node and the result, which will store all the paths. And I will always start the search at the root node, which is the slash. Okay, so my path will always start with a slash. And I will finally return the result. So once you have understood the main function call, let's look at all the APIs one by one. This is the trie node structure, which will be having a word end, and this will be true if a folder is ending at a certain node, otherwise it will be false. This is the map which will be storing the name of the folder, and there will be n number of pointers which will be pointing to the subfolders. Okay. Now once you have seen that, we will be looking at the trie insert. In this case, we will be getting all the folders one by one. So this is one valid folder that I need to insert. That means it is a single path which needs to be inserted. Like if I can say /a/b/c is one of the path. Now let's say you have already inserted this /a. And so the word end value will be 1 here, right? So what I'll do is I know that all the naming will start with a single slash. So /a/b/c will be starting with index 0. This will be 1, 2, 3, 4, 5. So index 0 need not be considered because the problem mentions that all the valid path starts with a slash. So I will be starting the parsing from I equals to 1 because I don't want to parse this slash. Okay, I will be skipping this slash. Now I will be iterating till the end of string just to extract all the path. First I will create a string name and then I will use a while loop and I will continuously parse this entire string until I see a next slash, because this could have been ABC or some name, right? So this entire name has to be extracted. So this entire name will be extracted unless I see a new slash or I reach to the end of string. So I will be taking out the entire string. In this case, it is just a single character. It could have been even longer. Now, whatever name you took, you will be storing it in the name, string name, right? And then we will go and check if current's word end is 1. So the current is actually the root node. Here the word end is 0. Okay. So this is 0 and therefore this will not run. And now what I do is I will be checking if the pointer to the child node is existing. So if I assume that I have already inserted A, then there will be a path which is present to A. So that means this is a non-null pointer, and so this will not run again. And we will be going to line number 21 where I will be just descending down to the child. Okay, and I will be doing I++. This I++ will actually skip this slash and go to the next value, right? That is why I have done this I++. Now again in the while loop we will be going and again the string name will be initialized, which will be empty, and I will be extracting the next name, and that next name will be B. Okay, so now the name variable is having B. Now I will be checking if the current's word end is 1, because if current's word end is 1, this means that already a main folder is ending at this point. So there is no point in making a new folder inside it. It will definitely be a subfolder and will not contribute to our answer. So this is implementing the pruning technique. And since I do not want to insert anything below this A, because already one of the valid folder is ending at A, therefore I will simply return from this point. Okay, we do not do anything. So this is how our trie insert will be going, right? And once you have understood the trie insert, after doing a valid insert, if there was no pruning, then I will be making the word end equals to true. Like if I had inserted A with a word end 1, but if I was inserting, let's say, B comma C, then I will be inserting B comma C and I will be making a word end equals to true here. That means word end equals to 1 and I will be returning. So you do not need to return a boolean here. You can keep it as a void function simply. Now let's look at the search trie, which is a simple DFS call. So let's assume that our entire file system is having this A, B, C, and it is having D, E. Okay, and here I have a word end equals to 1, here I have word end equals to 1, here I have word end equals to 1, and this is also word end equals to 1. So simply I will be doing a DFS call. I will be starting at this current node, which is the root node. Okay, so from here I will be checking if the current value, the node which we are seeing is having a word end equals to true. If that is the case, then I need to save my current path and just backtrack from here. But in this case, this is not having word end equals to true. So what I do is I will be looping over all the pointers which are present, and so I will be going to each of the child one by one. So first I will be going to A. So if I go to A, my path needs to be appended with the name and a slash. Okay, so initially what was my path? If you look at the function name here in the main function, I had actually passed a slash. Okay, so this slash will be already present by default in the path. So the path contains a slash. Now to this slash I will be appending the name, and what is the name here? It is A. So A will get appended, right? And then I will be appending another slash to it, and I will be making the next call. So when I make the next call, my current is at A, and it shows that this is having word end equals to 1. So we will be getting into line number 32. So line number 32 pop back is saying that I need to remove this last slash because a valid path is ending. So a valid path will never end with a slash. That is why I need to remove this slash. Okay, once you have removed this slash, we have slash A, and this is a valid folder name, and this needs to be pushed into our result. So our result will now have /a, and after this we will be returning back. That means we will be backtracking. Once we have backtracked, then from this slash the next pointer is going to this b. So our current will be descending to b, and my path will be having /b /. Okay, now I will be checking if this b is having word end equals to 1. No, it is 0. So I'll be iterating for all the pointers coming out of b, that means all the child of b. So I'll be going to c now. So c will get appended with a slash, and I will go to c. So my current pointer will go to c. Now from here I will be seeing if we have word end 1. Yes, we have word end 1. So what I do is I will be popping back the last slash, because this is making it invalid, so I'll be removing it. Now I have the name /b/c, and this will be inserted into my result, and we will be returning back. And similarly we will be repeating for all the nodes. So I hope you got the idea of how this code is working. If you still have any doubt, then feel free to comment below, and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.